Recording. Right, we're off. All right, so welcome everybody to week 2 of supply chain modelling and design. So this week we were having a look at some of the models, still using the principles of linear programming, but applying them to some other situations like transshipment, the idea of moving stuff through warehouses, and that of transportation as well. Just a couple of things we're just looking at this week. So I was sort of said with my introduction yesterday to the week, one of the important things is about the idea of these mathematical models is to get the language right, the nomenclature right. And the reason for that is because lots of people have been faced with these problems and worked out the best way of laying it out so it's easy to follow. And then it starts to become a bit of a language. So if people have done linear programming or process design, they're familiar with how they're laid out, the diagrams which are used, and they're just makes it easy to follow. Because I'm sure if you've ever been working with somebody and they've given you their lecture notes or something, it's very hard to make a head nor tail out of it. And similarly, if somebody had a look at your lecture notes as well, they'd have difficulty trying to work out what it's all about, but it means something to you. So if you were doing your own network diagrams, you might end up with your own way of doing it, which would be difficult for other people to follow. So the idea of just having a common language, a common approach to doing it. So that was basically what we're going to be spending our time looking at tonight. So the first half we'll have a look at network diagrams, and then the second half we'll have a close look at AT1, which is looming very large. All right, so I'll just start sharing my screen. So supply chain modelling design is what we're talking about. So it's just going off the example that we had in the book, just to make sure that everybody had an idea of what was going on. So this was basically the problem that we've got warehouses, plants 1, 2, 2 and 3. We've got customers. The plants 1, 2 and 3, and warehouses 1 and 2. And then we've got warehouses 1 and 2 there, and then we've got customers 1, 2, 3 and 4 across there. And then we have some constraints like capacity of 450, 600, 380, and then constraints on demand. So when we actually have a look at the diagram, I mean, this is just how it's expressed. So we've got the plans 1, 2, 3. We've got the warehouses 1 and 2, and I must admit I do think this is a big flaw in network diagram. They could use something other than numbers, because numbers really get confusing. And if you weren't using numbers, why don't you actually relate to what you've got here? Whether you've got P1 for a plant 1 and warehouse W1 for warehouse 1. However, I suppose the idea is for the approach to be very generic, so you don't want to tie it down too much. And the other thing too is that really once you've given the information to the computer, it's symbolic anyway. So it even has less meaning once it gets to the computer. The computer is just going to do calculations based on it. So what we've got these are the plants, and they can send product to either warehouse 4, well, warehouse 1 and warehouse 2. And then from those warehouses, they can go to customer 6, 7, 8, and 9. So just using the numbers that we have there, so it's not too confusing. Now, just to make life easier, we've used the letter X, obviously, because X can mean anything. And this 1,4 means that it's coming from nodule 1 and it's going to nodule 4. And similarly, this one, X15, is going from nodule 1 to nodule 5. And 2,4 is from nodule 2 to nodule 4. And 2,5 is nodule 2 to nodule 5. The benefit of that is, firstly, we've got an X, so we've got an idea of means something. And then with the number, we know straight away that the first number is module, one of the nodules, and the other number is the other nodules, basically in this situation where it's going. And it just, like, this is like a very simple model, but if you can imagine if it was huge, if we're talking about global networks and hundreds of warehouses all around the world with all different plants, it would get quite confusing. So it would be very easy to get lost. So just by using that nomenclature, you know exactly when you see that's nodule 1 to nodule 4. So, and then similarly over here, we've got 4 to 6, which is X 4 to 6. And then we've got X 4, 7 and 4, 8 and 4, 9. And then 5, similarly, we've got those going the same similar ways as well. So, like, because the biggest difficulty really in doing these types of problems is just getting the information set. Because once you've got the handle on the information, you've laid it out logically, then it's easy to move to putting it onto a spreadsheet and then doing the calculations by Solver. And then with the calculations, so we've got the idea is that what we're looking at, so what the X means, it means from I to J. So that's A letter I to A letter J, could be anywhere, could be thousands of different numbers. So it's sort of just an expression that there's a couple of numbers in there. So it's the number of goods to be shipped from I to J. And then the objective function of this problem is to minimize Z, because we know this is minimizing the cost of actually moving these products. And so we've got 4x14. So we know that 4x14, well, we know x14 is there, and the cost of actually sending it is $4 from where we go, one to the warehouse. Yeah, so 1 to the warehouse, yeah, is 4, and then 1 to 7. Well, 1 to 2 is going to be 7. So numbers confusing. So what we've got there, so that's what the 4 represents. So it's going to cost us $4 for movement of product down the X14, and then 7 down the X15, and then 8 down the X24. So we've got 8. So the 2 to 4, so X24 is going to be that $8, right? So that's basically what it is. So this is just expressing the whole problem. So what we want to do is to find the minimum value along the movement of these goods, and this is basically the movement. So we've got nodule 1 to nodule 4, which is that first one. Then we've got nodule 1 to nodule 5, which is the next one. And then we've got nodule 2 to nodule 4, which is the next one there. And then we've got nodule 3 to nodule 4, so that's there to there, and the 5. So that number, if we relate back to the table, is the cost of actually sending them there. So that's just how we're expressing it in this calculation. Then the other thing is that we've got x1 4 to x1 5 must be less than and equal to 45, because the capacity for nodule 1 for nodule 1 is 450. So whatever moves from 1 to 4 and from 1 to 5 can't exceed 450, because that's all we got. And then from plan 2, so we've got x24, so 2 to 4 and 2 to 5. So similarly, that has to be less than that capacity of 600. And then for here, so that's nodule 3 to nodule 4 and nodule 3 to nodule 5 can't exceed 380. And then, so that's on the capacity side. And then when we look on the demand side, we've got custom one, so that's X46 and X56. So X46, so that's 4 to 6, and from 5 to 6. So because these are the two warehouses, so they're all coming into there and then coming out of the warehouses to the customers. So this one can't exceed 300, or the demand is going to be less than 300, because that's the maximum. If you remember last week when we were talking about how many biscuits were sold, that it had to be less than the actual capacity, which could fit into the oven. Well, it's the same sort of thing. So the demand is not going to be greater than 300, so it's got to be less than 300. And then customer 2, so there's X47, so 47 and 57 and 57 is 300. And then so we've got 300, 300, 300, and then 4858. So 48 and 58 cannot exceed 300. And then 49, so 49 and 59 can't exceed that 400. And then when we talk about the warehouses, so we've got warehouse 1 and warehouse 2. So we've got that the flow in, so this is X14 plus X24 plus X34, so 142434 must equal X46, X46, X47, X48 and X49. So it's just balancing up the flow that it comes in and goes out. So that's why we have the equal sign there. And then similarly with warehouse 2, which is that nodule 5. We're going to have the same thing again. So they have to balance, so that you can't send out more than what can be received somewhere else. But the capacity that the plants have are those, and the demand for the customers want is over there. So that's just the balancing thing. And then the final thing here is just a final constraint, is that there's a non-negativity. So we're just saying that X to Y, so everything shipped from I to J must be greater than or equal to naught. So we don't want any negative numbers. That's pretty exciting, isn't it? So any thoughts about that? Does that seem a lot clearer now?
Yeah.
How about you, Troy? I'm still just trying to find.
Sorry. Hi. Yeah, that does look a bit clearer. Yeah. Seen it in graphical form laid out really helps.
Yeah. Because it does, these network diagrams, they do get a bit confusing, for sure. But once you understand the nomenclature, the formula, how they're put together, then it makes it a bit easier to read them. All right, so I'll just go on to the next bit. So I'll just go back to sharing. Oops. So the next thing then was to put it into a spreadsheet, and so I was going to just go through and would just read the cells, but we're not going to be able to see it there. So just bear with me. I'll just call it up. Modules. Oh, I've got my downloads. Yeah, there we go. So this was basically the solution. So I'll just, I think the problem with the solver was that, I know, we probably just moved it around. So this is basically the solution. So to set the objective, this is set the objective. So this is where we want the lowest cost. Now, the reason why there's the dollar signs in front of the cell coordinates is just to make them reference cells. Because what happens with a spreadsheet, if you do a calculation, and if you drag down, because you can actually copy a calculation just straight down, and what Excel does is sort of just moves and goes down to the next line, and it will constantly be doing that unless you set a reference cell. And once you have a reference cell, it means then that Excel will keep going back to that cell. So that's just why you see all these dollar signs in the formula, because they're just setting that cell as the formula. Then the next thing was changing the variable cells. And the variable cells is J3. So we've got J3, which is there, to J5, which is that one there. So these ones in yellow here are going to be changed, and they must be less than or equal to K3. So that's K3 to K5. So if you remember, these are the constraints that we've got from the information. It's the output for the from the plants. And then warehouses. So we've got warehouse 1 and warehouse, where are we? J8, so J8. Yep. So then this next one is J8. So that's J8 there, cell J8 to J20. So it's right down here somewhere. I think we've got anything in there. That might be a bit excessive. And then we've got the must equal K8. So that's K8 through to K21, all those. So if you remember, that was the same with the biscuits from last week, where we were saying that we've got, these are we want to know the quantity that we can make, but this is the maximum number that we can make of those particular cookies. So then the variable, what was going to change, had to be exactly equal to what the maximum sales were for the item. So that's just what we've got there. Now, don't worry too much about this, because there's just different ways of doing these calculations, but just trust Excel when it just throws up a method. And then the next thing after that is just to press solve. And then if we just look what we've got in these cells, so this A3 to A16 is the changing variable cells. So these are the cells which are going to be changed there, and this, I'll probably have to close that. And this is the sum product of A3 to A16. So A3 to A16 and F3 to F16. So what this function is doing is multiplying that by that to give us that. Now, how to use that sum product function? There are some tips within the course notes which just outline what needs to be done with the formula. But let's see what it tells us. So if we go, so sum product returns the sum of the product of a corresponding range of arrays. So like, it's pretty easy. We've got A13 to A16, which is one array. So that's just a collection of cells. So that's just straight down there. And the second array is F3 to F16. So that's F3 to F16. So what it's saying is you're just multiplying this array by that array. How easy is that? Gosh, you thought this was hard. This is child's play. So that just works out what the total cost is, and then of course the solver. So the solver, when it does this bit, is working out what needs to come from where. Now, how this works is that this calculation is just going in the background, and it's just going line by line and line by line to see if it works, and if it doesn't, it just starts again until it finds a solution. There's nothing real magic about it, but because it happens so quickly, you think, oh, that's pretty clever. But a computer, it can only do 5 things. It can on or off, recognize the same, add or subtract, and what was the other thing? Greater than or less than. But like, there's only really 5 things that a computer can do. The clever bit is really in the programming, when you get all these little things that a computer can do, and then you stick them together, and then you can get these complicated calculations. But so, like, just don't be scared by computers. It's all froth and smoke, really. When you get down behind it, you think, it's only, even, I mean, it doesn't even multiply or divide. All it does is sort of just works out an integer and just adds them together, and that's your multiplication. So I don't know if did you ever do logs at secondary college? Yeah. So that was the example where you work out a number to its log of a particular number, whether it be 10 or something, and then you just add stuff, and that's basically a multiplication. Very good. Right, so any questions about that? You sure, Crystal? You look a bit gobsmacked there.
Oh,
Wonder-
no, I'll be watching it again, but yeah, to see it done.
Yeah, the best thing is just to give it a try, just to give it a bit of a practice, and that sort of helps too, because you think, oh yeah, I know how to do it, and then when you do it, you think it didn't work out, and then you go back and you find out, oh yeah, there's a little step I missed. Yeah, but look, it's really not that hard. A lot of it is just understanding how you lay out your network diagram, and then once you do that, then you can transfer that then to your spreadsheet and do the solver. All right. Well, that was basically this week's topic. We're going to have a look at the first assessment task. So I'm just going to stop now, and so I end up with two videos. So I'll just stop momentarily. Let's pause. I've got to stop recording.